Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. Thank you to all my new subscribers and everyone that's been leaving me comments. This is officially part 2 of the tapping series, and it may go to part 3, I'm not quite sure. It depends on how lengthy this all gets. If you didn't have a chance to watch part 1, I got some great comments, and I actually learned quite a bit about the terminology and the types of taps that are available, especially in the UK. Got a couple of corrections, and seems that what we call our plug and bottom and blah 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 is a little different than what they did. So if you didn't have a chance to read the comments in part 1, go read the comments. I found some of it very interesting, and thank you to the guys that took the time to type that out. Today we're going to run across a couple of the more specialized taps, a little bit deeper terminology, lubrications, tools, and we'll go out to the shop in a little bit and I'll show you some of the tools I drive these things in with, and we'll go over some fairly creative setups. I want to start this off by saying there are many different types of taps for many different situations, styles of parts, and one that you're going to probably need sooner or later is a thing called a pulley tap. Now a pulley tap is, if you can imagine, you have a pulley and you have your little hub on that pulley and there's a tapped hole in it. Well, if your tap can't get from here to here, it's no good, right? So a pulley tap has an exceptionally long shank on it and a standard tap head. They're also called extension taps. So if you go to the catalog and you're looking for a pulley tap and they don't have any, look for a thing called an extension tap. Now it's not only good for pulley applications, but when you have a part or a flange that has a bunch of holes in it this way, and there's a large boss on that part, and you got to get down alongside that boss, a pulley tap is good for that too. Well, depending on how much room you have between your boss and the center line of your hole, you could probably do it with a standard tap, but just get an extended T-handle. They make those as well. You know, most of the ones you're going to find, depending on the capacity of the gripping area of that T-handle, it's going to be a fairly standard length, but they make them really long just for stuff just like this. So that's a pulley or an extension tap. And if you don't know they exist and it comes time to use one, chances are you're going to get a piece of stock and you're going to braze a tap on it, and you're going to do the job, and then you're going to find out a week later that you could have bought one. So trust me, I think that's what I did. Okay, the flutes on a tap. Flutes on a tap, they do different things like I reviewed in the first part. If you have a tap body, let's say this is a 4-flute tap. If the flute of the tap is straight, then naturally it's a straight flute tap. If the flute of the tap has a slight helix to it, like an end mill, it's going to cut better, and depending on which way the helix goes, it's either going to bring the chip up out of the hole or force it down into the hole. The ones that force the chips forward are better for through-hole applications. So 2 types of flutes: straight flute, spiral flute, and then you have the ones that are called a high spiral flute, which I showed in part 1, which looks like an aggressive spiral staircase, and then they really pull the threads out of the waste material out of the holes. And I'm going to set one up in a tapping guide. I'm going to show you exactly how that works. It's pretty cool. Pipe taps. We talked about pipe taps in the last one. A pipe tap is a tapered tap. Naturally, the further in you drive it, the more surface engages, and these things can get pretty tight to drive down into material. Now there's 2 things that you can do to help you with the pipe tap application. You can pre-ream the hole with a tapered reamer, and the reamer comes the same size as the tap, so just if you're looking for a specific size pipe tap, get the reamer that goes with that. If you do not have a thread gauge for a pipe tap, I know that I personally do not have tapered pipe tap thread gauges, and what I've done is, after I've run a good hole, I blew up my tap and I scribe a line on that inside of that shank, and I'll just run the tap down to that line, and God forbid that line ever comes off. I'm going to have to freak out. I don't know. Anyway, that's one way of relieving the pressure on a pipe tap. Pre-ream the hole. There are also pipe taps called interrupted thread pipe taps, where depending on how many flutes you have, and chances are it's going to be a 4 flute, the teeth are removed in such a manner that every other tooth does some cutting, and the ones in between complete the helix. So realistically, when the drag comes along to drive the tap in, you don't have as much resistance with that pipe tap because you have an interrupted cut or an interrupted flute. And that's exactly what it's called. It's an interrupted thread. And if you have an interrupted thread that's a mide spiral, it cuts even better, because when you start introducing a spiral into it, it has more of a scooping, more of a shearing action. So keep that in mind. A lot of times on a tapered pipe tap, you have to engage a substantial amount of that tap body into the part before you get a gauge thread. Well, they make reduced length, short projection, I believe it's called, pipe taps just for things like that, just for shallow hulls. So if your gauge dimension or your gauge point of your tap is at a certain length, well, these taps, they just end a little bit shorter. So if you have a narrow plate or whatever the application is, you can buy those as well. Beats taking a real nice tap and just grinding it down to nothing, right? You might as well have one of each in your box, so make the investment on that. Alright guys, if you just witnessed a little blip, got a battery warning on my camera and I just readjusted it, so excuse the edit. Talking about Acme taps. Acme thread can be relatively hard to drive in because it's a deep thread, and when you run an Acme thread you can get what's called a tandem tap. So it's like a starter tap and a finish tap all in one long body. The first half of the tap is a starter thread and the second half of the tap is the finished diameter and the finished profile of the thread. But you have to drive it all the way through your part. So if you're making a bushing or a knob, or use something that you can push the tap all the way through the part, then a tandem tap is a good thing to get. Handles. You can have a straight tap handle, many different sizes depending on how big your tap is. You can have a T-shaped handle, which is exactly what it sounds like. It's a T. You can have extremely small handles, and I have handles that I've made that are also stops for the depth of the tap. It's a collar that goes around the body of the tap and it's got little screws on it. I'll show you those in the shop. And one of the best things that I've ever used for tapping real small holes is about 1.5 inch diameter aluminum knurled wheel that you just put right down over the tap body, set screw, and when you dial that tap in, the feel that you can get for the smaller taps with a knurled wheel is so superior to the T-style handles, it's not even funny. So take a couple of minutes and make one of these. If you haven't, you should. Okay, well I think I skipped over one tap and I was called out on this on the first part. And this is a reduced shank or relieved shank tap. And I am familiar with the Emugi brand taps, E-M-U-G-U, Emugi. And all that is a very short threaded section on a tap, and then it necks down. Now these taps are good for CNC applications because they're exceptionally strong, and they can also be purchased in spiral point, or excuse me, spiral flute, straight flute, a variety of different kinds. Some of the larger taps you can buy would be a reduced shank, so if this was a 3/4 thread, you don't want a 3/4 shank on that, you can get a 1/2 inch shank on it and it will serve the same purpose as some of the smaller reduced or relieved shank taps. Coolant, lubricant. The 3 lubricants that I use exclusively here in this shop, and I've trusted them for years, are Molly D, molybdenum disulfide I believe it is, and my manufacturer is Castrol. I'm sure you can get it from other people, but Molly D is one. They call it goose grease. Nastiest stuff you ever want to work with, but it hangs onto the tap in a high pressure application for tougher steels. Good stuff to use. Tap Magic makes a variety of different chemicals, but the Tap Magic tapping fluids that I have are for aluminum and stainless, and the Tap Magic for aluminum is amazing. You can use kerosene in a pinch on an aluminum piece and tap goes in and out. Beautiful. The WD-40 trick, occasionally a lot of guys are going to say, oh my God, WD-40 is not a lubricant. It will work. It's not a suggested high pressure tapping fluid, but if you get stuck, you can use it. So we have the reduced shank, relief shank, cutting fluids, the Acme tandem taps, just in case the camera kicked out. I changed the batteries on it, so forgive me if I'm duplicating this. Acme threads can be very hard to push in. They have a thing called a tandem tap. Looks like 2 taps end to end. First half is a starter thread, second half is a finish thread, but it's got to go all the way through the hole. It's called a tandem tap. Look it up. Okay, let's take a walk out to the shop. I'm going to show you the handles that I have available to me. They're limited, but the collection is narrowed down to exactly what serves my purpose, and these tools have been in my box for 40 years, with the exception of the tapping head. That's a new addition to the shop, but that's a little pricey object, and maybe not everybody wants to invest in one of those. All right, let's take a walk out, take a look. Okay guys, at the recommendation of some of my viewers, I've changed over to a gray background instead of my oak top bench, and we're going to see if that makes a difference in the quality here. I'm going to start off with a T-style tap handle. Come in a variety of different sizes, and it's based on the square on the end of your tap, which one it'll take. I'm sure they're rated somehow. These are US General. They're not expensive. You get what you pay for. Some of them are ratcheting so that you can continue to drive them in, change it, and drive the tap out. So that's a T-style. And one of the things that I've also done in the T-style mentality is to make this little guy here that not only is a T-style driver for smaller taps, but the relieved shoulder allows you to set the depth of the thread rather easily. What you can still use a straight style handle on this or a T-style handle, it really doesn't matter. I have those in a variety of different sizes depending on the shank of the tap. They work very well. They're easy to make and they're quick and they hang around forever. This is a straight style handle. Self-explanatory. And they do come in a variety of different sizes. And this is one that I made for extremely small taps. Set screw in the end. Comes through to the center. This goes down over the shank of the tool, and I put a small flat on the shank and in it goes. So those are straight. Now when you're driving taps, chances are you're going to come up against one of these. It's going to have a point on the end or it's going to have a hole in the end. Now I've seen a lot of different guys use a lot of different attachments, and this is one of them. This is a tap guide. This is a spring-loaded tap guide. And it has a cup point on it so that when you use a tap that has the conical feature on the end, they go together real well. And it preloads spring pressure, so if you're using it in the tailstock of your lathe or a collet in a CNC or a drill chuck, you just put your tap in the hole with the handle already on it, drive this down on top of it, and it applies the pressure, and as the tap goes in, the handle extends. Now, one of the things that I've seen online that I'm not sure if I'm the only one in the world that knows this or not, probably not, but on this particular attachment, if you take the spring out, you can adjust the tension on the tip here for different size taps. If you're driving in a real big tap, you want a lot of pressure on your spring. If you're driving in a smaller tap, then lighter pressure. So just buy yourself a variety of different size springs. Excuse me. Excuse me. Now if you take the tip out, there's a cup on one side, there's a point on the other. All the videos I've been seeing online, nobody seems to know that there's a point on the other side. Take the tip out, reverse it, put it back together, and now you have a pointed, which are good for the taps with the holes in them. Center it up, away you go. Okay, you can also put your tap in the holder. And put your tip in the center on the end of the holder and just drive the whole thing in line. But there will be a greater possibility of misalignment between components, so be careful if you do it this way. If you need a precision straight hole, I like to use a straight handle and stay as close to the tap as I can with the tap guide. Well, unquestionably my favorite tapping attachment is this guy right here. This is the Tapmatic RX50 auto reversing tapping attachment, and the maximum tap that this thing is suggested to drive in is a 5/8 16. This shows you the capacity. When you buy it, make sure that the capacity on your unit, let's see if I can change that light so you can read it. Let's try that. The capacity on your unit will be called out, so you have a metric M3 to M12 or number 6 to a ½ inch, and the difference in the taps dictated by the little rubber collets in the front of this unit. So you unscrew this, pop your collet in, screw the cap back on, and as the cap screws down, this is the neoprene rubber, and it squeezes these little holders against the body of the tap, while the flats on the top of the tap are controlled with this screw right here. It's a floating block that will grab the flats on the end of it, so when you load it up, nice and snug on the shank so that you can still spin the tap, then tighten this up, and then torque the collet down, because you can load a tap in here sideways and it'll wiggle and it'll run out. Depending on what size tap you have in here and what material you're driving it down into, the ring on the top is adjustable, and as you turn it and this ramp disappears up into the darkness, you'll know what size tap the tension on your unit is set for. And this is a magnificent attachment. It is pricey, so if you buy one, make sure that you buy it to accommodate the range of taps that you normally use, or you're going to have to buy another one, and these things can be very expensive. So we're going to put that on the machine, and I'm going to show you the performance difference between a spiral point and a gun tap for chip control. Okay, let's take a walk over the machine, check it out. Alright guys, I'm going to tap 3 different kinds of holes here. Actually, I'm going to tap the same hole using 3 different types of threading tools. First one is going to be a 4-flute, straight flute, 1/4-20 taper tap that I'm going to drive in by hand. I always chamfer my hole before I thread it, so you don't roll the top thread down into the hole. I'm going to use our little spring-loaded tap guide that we went over inside. I'll show you how that works. I'll do this one by hand. I will check my focus here in a second, so bear with. Now, since this is a straight flute taper tap, depending on how many times you turn it as you're pushing it in, you can either expect the chips to pack up in the flutes or push forward to the hole. As much as I don't like using a 4-flute on aluminum, this is the only one that I had for the demonstration, so we're just going to go with it and see what happens. I'll show you the difference in efficiency. between this and the other two styles. Taper taps are historically designed for tougher materials, so I am swimming upstream with both of these characteristics on this. 4 flutes and tapered. Not exactly ideal scenario. That's as far as I'm going to go, just to see where the chips are. And I'm going to have to bet that they are packed up in the leads of this tap. Which they are. And you can see them coming out with the tap. And a very small pile underneath. Next tap I'm going to use is the spiral point plug tap. And if you're in the UK, that's not a plug tap, right? It's something different. There you go, that took way too much time. This is a nice little attachment. If you don't have one of these, get one of those. You'll use it 1,000 times. And I'm going to shift off center here. 300 thou. Since this is a 1/4 hole, I want to make sure they clear it. Naturally, anytime you're going to drill through a piece, make sure your parallels and springs and everything else underneath that part are out of the way, or you're going to end up with a whole lot of disappointment for the day. I will be power tapping this. I'm going to use this spiral point plug tap. You can see it's got the secondary relief, so we can expect these chips to blow forward underneath the hole. I'm going to change the angle of the camera so that it biases underneath the part, and you can see the chips push forward of the hole. If you do this, make sure that your lock on your quill is unlocked, that it's nice and free, and that you have a scrap piece that you can experiment if you've never done this before. You don't want to drive down real hard on the handle and force the teeth not to cut in the helix that they're trying to cut in. So I'm going to put this in back gear, slow it down a little bit, just to show you the tip will force the chips down. So a through hole application, good. Bottom hole application, not so much. Okay, as promised, those chips came right out the bottom of that hole. And there they are. Both flutes of the tap, the chips combined, comes out in like a little tornado looking thing. And you could imagine if this was a bottomed hole, that this would all be compressed and smashed up in the bottom of that hole and take a considerable amount of time to pick out. That was a spiral point plug tap. Next one I'm going to do is a high spiral plug tap, 1/4. And we're going to assume that this is for a bottom hole. I'm going to go 300 in the opposite direction. Back in high gear, here comes the hole. Well, I tell you, if you don't have one of these keyless chucks, you got to get yourself one. It is such a time saver. Okay, for the hole. Now the high spiral tap, the one that looks like a spiral staircase, these chips should come out of the hole on independent sides of the tap just beautifully. So if I don't blow this tap up, let's take a look and see how this is going to prove out. This is the high spiral, and watch the chips come off this tap. Beautiful. Pop this into neutral, and you can see the geometry of the tap forces those chips to cling to the tap, come right up out of the hole, and if you look under the part, there's nothing under the part, and if this was a bottomed hole, the hole would be absolutely clean. High spiral taps, I love them. Takes the secondary work out of the equation. Nice and quick. Alright guys, that's 3 different types of tap. Manual tapping, power tapping. Power tapping, once again, on the way in, you'll feel the spindle start to pull down as the tap starts to cut. Keep a gentle pressure on it as it's coming down. When it's coming back up, feel the feed rate and try to anticipate the feed rate as the tap clears the hole. If the spring jerks the tap out of the hole real quick, it may elongate the top thread, and when you go to put something in it, you're going to think it's no good. But if you go about a half a turn down and put a little bit of radial pressure on your screw, it'll realign the top thread and everything will fall in pretty nice. I'm going to drill a bunch of holes in this part and put the tapping head in. So I'm going to cut out now, and then we're going to come back and I'm going to show you how fast the tapping head can do a dozen or more holes in this thing in a matter of seconds. Anytime that you elect to freehand chamfer or drill any material, even if it's in a vise, make sure there's something to stop the rotation of that. One of the things that I see a lot on drill presses, somebody will strap something in a drill press vise and then freehand it and not even realize that the entire vise can spin. So please secure your work. Alright, bunch of holes. I'm going to tap those holes short order. I'm going to set up the tapping head. I'll be back in 2 minutes. Okay guys, I have the Tapmatic head set up in the machine. A 3/4 collet. And I've used linen phenolic on the back. Some guys use rods that come down on the side of the spindle, and that's, it works fine for some people, but this is my preferred method. This linen phenolic is incredibly strong, and it's secured to the back of the stationary jaw with the half 13 screws that secure the jaws as well. Now when you set up one of these heads, you have to realize that there's a degree of float in the front of the tapping head itself, the mechanism itself. So as it comes down, this will pull down out of the head on a heavy spring until it engages clutches inside that then reverse the direction. So when you first set your part up, you have to be very careful to not drive it in so far that when you hit your solid stop with your quill and your spring takes over inside your tapping head, that you don't exceed the threads on your tap. So the first hole, you have to mess with the first hole for a minute, and that's exactly what I'm going to do, and I'm going to show you. It's going to make some noise, it's going to rattle, but that is absolutely normal. I know this head extends about 400 thou from the time it hits the stop. So I'm going to bring the tap down till it just touches right there, and I'm going to set my stop on my machine to about 400 thou. One of the beauties of these tapping heads is this thread will actually re-engage. It'll find itself. If you pop out and want to go back in the same hole, somehow by osmosis, I don't know, it's a great engineering, this tap will actually refine those threads and not double up on the threads. Maybe one out of every 10,000 threads will you cross up the leads. So let's take a look and see how this works. This is a 2-flute bright plug spiral point tap. So you're not going to see too many chips come back out of this hole. It's going to blow it all underneath the part. And no, I'm not going to slow it down. That was pretty quick right there. Let's set it a little bit deeper, and I'm going to show you what I mean by it will pick up the existing thread. And away we go. Going to go a little deeper. Okay. We have a beautiful 1/4-20 thread in this hole. Pop it out, lay it sideways so you can see it. Let's see if the autofocus treats me right. Here we go. I wish it was manual focus, guys, but it is not. There's nothing I can do about that. I could go macro, but that's just not going to work. Alright, well, you're just going to have to trust me that there's a nice thread in that hole. Now, many years ago, I was confronted with a job at a job shop that I was working at, and we had to do, or I had to do, 700 holes. And although this is quick, moving from hole to hole can be a real problem. So I'm going to show you the setup just because I thought it was cool, and if it's something you could ever use, by all means, keep it in your bag of tricks. We're going to repurpose these parallels. Just 1 second. This is a replica of the setup that I made for those 700 holes. Get yourself a piece of scrap stock or parallel or whatever you can grab that's just a little bit bigger or exactly the same size as the parts you started with. Slightly larger by about 5/10 thou would be absolutely ideal. But if you don't have that laying around, that's where Mr. Post-it Note comes in handy. I'll lay one piece of paper here. I'm going to lay another here. And you'll see why I'm doing that here in just 1 second. Now I'm going to take a third one, split that in half, put these parallels back in on top. Now if these were a couple thou bigger than the material, that would be ideal. And since they're not, I'm going to cheat the upper jaw with a piece of paper. Lock it down. Now with any kind of luck, this will slide right out, which it will. Now what I have is a channel perfectly suited for the part. It's trapped rotationally, it's trapped vertically, and the tap will pull this thing into line. And I don't know if you can see it or not, but there's only one of these holes that's tapped, and I will not accelerate this camera speed for this operation. This is real time, so let's see how fast you can do that. And believe me, if you had a whole skid of these parts sitting there, you'd want to get creative. And this is about as creative as I can get. Okay guys, that was real time. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 quarter 20 through holes. Half-inch 6061 aluminum. I wasn't counting on how long that took, but that didn't take any time at all. Okay, well that's it. Saw the tool, saw the tapping head, saw the sliding fixture. Really like this. If you have a bunch of holes in a long bar that you need to do, this works like a charm. Please don't ever freehand drill or countersink any material that doesn't have a rotation stop. You don't want to saw your fingers off. And that's all I got for you on the shop floor today. Okay guys, well I hope you enjoyed the demonstration out in the shop. That tapping head is a really nice thing to have. The manual power tapping in a drill chuck will take some getting used to. If you try to do that, you're going to blow a couple of taps up, you're going to pack a few holes up. You are going to strip a couple of threads out, but in the long run, the time spent is well worth it. I hope you enjoyed what you saw. If you have any questions, comments, please leave them in the comment line below. Please be kind. And if I skipped over anything or anything I said is a different tech terminology in your country, by all means, tell me what it is. I really enjoy all the technical information coming in from the UK and elsewhere. So thank you for that. That's all I got. I hope you enjoyed it. I don't think there will be a part 3 on tapping unless, of course, feedback demands it. Until then, Joe Pazinski, Advanced Innovations, Austin, Texas. I'm out.